Alright, let's go. Number 10. The rubber hand illusion. In 1998, Matthew Botvinnik and Jonathan Cohen at Princeton were studying something unglamorous, multisensory integration, how the brain merges touch and sight. They were not hunting for a way to hijack the sense of self, they were trying to map basic perceptual wiring. Standard neuroscience assumed body ownership was hardwired, that you know which hand is yours the same way you know your own name, through some direct, unmediated signal from the nervous system. No inference required, no room for error. Then they placed a rubber hand on the table and hid the real one. They stroked both at the same time. Within minutes, subjects reported feeling the touch in the fake hand. Botvinnik and Cohen published the result in Nature in 1998. Follow-up work measured skin conductance spiking when the rubber hand was threatened with a knife. fMRI scans showed premotor cortex activity tracking directly with how strongly a subject felt ownership. Thermal imaging went further. The real hidden hand's temperature measurably dropped as blood flow was redirected away from the limb the brain no longer believed was its own. Researchers tried to explain it away. Maybe it was suggestion, but blindfolded controls without synchronized stroking felt nothing. Maybe it was proprioceptive drift alone. But the skin conductance and thermal data showed the effect ran deeper than misjudging location. Every deflationary explanation left the temperature drop unaccounted for. The body was not just confused, it was acting on the false belief. A third camp argued the effect was purely cognitive, a belief update with no real physiological weight behind it, more opinion than perception. The thermal camera data closed that door for good. Blood vessels do not constrict for an opinion. Something below conscious belief had already accepted the swap and started reallocating resources accordingly. Your brain does not perceive ownership of your body. It infers it continuously from correlated signals, and that inference can be redirected by a stranger with 2 paintbrushes in under 60 seconds. What else about your experience of your own body? Its boundaries, its location, its very belonging to you, is a guess your brain is making right now. One you have never been given a reason to doubt. Every one of these cases starts the same way. A scientist looking for something ordinary. Number 9. Hemispatial Neglect. Clinicians working with stroke patients in the mid-20th century were tracking routine motor recovery. Arm strength, speech, mobility, spatial awareness was not the focus. It was assumed to be intact unless a patient reported vision loss. The standard assumption, consciousness of the visual field, is uniform. If the eyes work and the visual cortex is intact, the whole field should register. Then, patients with damage to the right parietal cortex started drawing flowers with only the right half of the petals. Asked to bisect a line, they marked it far right of center, as though the left half did not exist to be measured. The pattern was documented across decades of case studies and formalized in behavioral neurology through the 1970s and 80s. With reproducible results, patients asked to describe a familiar room from memory would report only furniture on the right. In the most severe cases, patients denied ownership of their own left arm entirely, a condition termed somatoparaphrenia. Insisting it belonged to a nurse, a stranger, sometimes trying to throw it out of the hospital bed. Doctors first suspected pure blindness, ruled out the eyes and primary visual pathway were intact. They suspected motor neglect, a failure to move the left side rather than perceive it. Ruled out patients could move the arm when reminded, they simply did not initiate awareness of it. They suspected the patients were malingering or confused. Ruled out, the confidence with which patients denied the arm was theirs matched the confidence of any accurate memory. The right parietal cortex does not report on space. It builds the conscious half of it. Destroy that region and the world does not go dark, it simply stops being represented. And the patient has no way of knowing anything is missing. The world you are conscious of right now is assembled by regions of tissue that can fail independently, silently, without leaving a gap you would notice. The stumble was never the goal. It kept finding the researchers anyway. Number 8. Blindsight in the 1970s. Lawrence Weisgrentz at Oxford was studying patients with damage confined to the primary visual cortex, V1, a narrow technical question about which brain regions process which visual features. The prediction was simple: destroy V1, and vision in the corresponding part of the visual field is gone. Not dimmed. Gone, no image, no report, no behavior tied to it. Weisskranz's patient, known in the literature as DB, insisted he saw nothing in his blind field. Then, asked to guess whether something was there, he guessed correctly, again and again, far above chance. Weisskranz published the case in Brain in 1974, coining the term Blindsight. Later studies by other groups found patients navigating cluttered corridors without collision, in fields they reported as blank. DB himself, in later testing, could reach out and catch an object thrown directly at his blind field, accurately, before it arrived, while maintaining that he experienced nothing. Skeptics proposed scattered light was reaching intact peripheral cortex. Controlled trials with tightly restricted stimuli ruled that out. Others proposed patients were unconsciously guessing based on subtle cues, but the accuracy for motion and orientation approached that of sighted controls, too high for chance-level guessing dressed up as intuition. The processing was real. The seeing was not. Visual information can enter the brain, get processed with precision, and drive accurate behavior, while consciousness of it never switches on. What you are aware of and what your brain is doing with information you have already received are not the same event. Blindsight is the proof that they can separate completely, and you would never know from the inside which one was happening to you. No explanation held, everyone collapsed on contact with the data. Number 7. Alien hand syndrome. Surgeons in the 1940s performed callosotomies, severing the corpus callosum between brain hemispheres as a last resort treatment for severe epilepsy. The goal was seizure control, nothing more. The assumption: a person is one agent, one set of intentions, coordinated seamlessly by a brain that functions as a single integrated system regardless of the anatomical split. Then some patients began reporting one hand acting on its own, unbuttoning a shirt the other hand was buttoning, reaching for food the patient had no intention of touching. Cases were documented extensively through the 1970s and 80s in patients following callosotomy and afterstrokes affecting the supplementary motor area and anterior cingulate cortex. In the most severe recorded cases, termed anarchic hand, one hand attempted to grab the patient's own throat, while the other hand fought to restrain it. Doctors first considered psychiatric explanation, dissociation, conversion disorder. Ruled out, the movements correlated precisely with damage location, not psychological history. They considered simple motor reflex, unrelated to intention. Ruled out, the alien hand pursued goal-directed, context-appropriate actions, not random spasms. It was choosing things. The right hemisphere, cut off from the language-dominant left, keeps generating its own motor plans. The left hemisphere, which produces the verbal sense of I, experiences those plans as foreign because it was never consulted. The single, unified you making decisions is not a guaranteed unit. It is a product of connectivity between two halves of one skull, and when that connection is severed, two agents can occupy the same body, one of them occasionally at the other's throat. None of these researchers went looking for the disturbing version of the answer. Number 6. The missing neural correlate. Neuroscientists across dozens of labs spent decades on a well-defined technical goal: locate the neural correlates of consciousness, the specific brain activity patterns reliably tied to subjective experience. It was meant to be a solvable problem. The expectation, formalized clearly by the 2010s, a consistent signature should exist, some pattern of activity present whenever and only whenever. Consciousness is present. In 2023, a pre-registered adversarial collaboration testing integrated information theory against global workspace theory, published with results circulated widely in the consciousness science community, found the predictions of both theories failed to cleanly separate from the data. Neither was confirmed. Neither was fully refuted. That was only the surface problem. Studies of experienced meditators showed dramatically different neural patterns underlying subjectively identical reported states compared to non-meditators. Patients with locked-in syndrome demonstrated full conscious awareness with minimal EEG signature. Some anesthetized patients later reported conscious experience during procedures with no corresponding EEG marker flagged at the time. Researchers proposed a universal correlate simply hadn't been found yet. More data, better instruments. 30 years and improved scanners later, no candidate has generalized. Others propose the correlate varies by individual but is still fixed per person. Longitudinal data undercuts even that. Correlates shift within the same person across different states. The relationship between neural activity and experience may not be a fixed mapping at all. It may be far more variable than the entire research program assumed when it began. 30 years, a global research effort, and the most basic question, what pattern of matter equals experience, remains unanswered by design, not by lack of effort. The failure parade never ends. It just changes which explanation dies next. Number 5. Electrode-induced out-of-body experiences. In 2002, Olaf Blank at the University Hospital of Geneva was mapping seizure foci in a 43-year-old epilepsy patient, routine pre-surgical electrode stimulation. Standard clinical procedure to locate the source of her seizures before removing it. The expectation was localized, mundane sensory responses, a twitch, a flash of light, a tingle, nothing resembling a shift in the location of the self. At 3.0 milliamps to the right temporoparietal junction, the patient reported sinking into the bed. At slightly higher current, she reported watching herself lying in the bed from above, a textbook out-of-body experience reproducible on command, vanishing the instant stimulation stopped. Blank published the case in Nature in 2002. In 2014, his group at EPFL extended the finding using full-body illusions and vestibular manipulation, confirming that the temporoparietal junction integrates visual, tactile, and balance information to compute where you are located relative to your physical body. Skeptics proposed a seizure artifact unrelated to the stimulation, ruled out by the precise, repeatable current-response relationship. Others proposed the patient was suggestible, primed by clinical context. Ruled out, naive subjects in later vestibular studies reported the same displacement without prior expectation. The felt location of your consciousness, the sense of being behind your eyes rather than 3 feet to the left, is a real-time calculation performed by a specific patch of cortex. Apply the right current, and the calculation changes. You move without your body moving at all. If where you are is a computation, then where you actually are right now is a claim your brain is making that has not been checked. Nobody sets out to find the version of physics, or mind, that breaks the rule. Number 4. Synesthesia. Francis Galton first documented colored letter perception in the 1880s while cataloging ordinary variation in mental imagery across the general population. A survey project, not a hunt for a sensory anomaly. The standard model of perception held the senses were cleanly separated channels, vision here, hearing there, no crosstalk in a typical brain. Then a consistent subset of the population, roughly 4%, reported that specific letters and numbers reliably triggered specific colors, immediately, involuntarily, unchanged across decades of their lives. Modern fMRI studies, including research published in Nature Neuroscience in 2018, show grapheme color synesthetes activating color area V4 in response to achromatic black letters, activity absent in non-synesthetic controls. Behaviorally, synesthetes locate a target digit hidden among distractors faster when their induced color differs from the surrounding digits, a measurable performance advantage from a color no camera would ever record. Early researchers proposed synesthetes were exaggerating childhood memory associations, essentially reporting metaphor as sensation. Ruled out by the brain imaging, the color activation is real, physical, and involuntary, not a linguistic habit. Others proposed it was a rare pathology, a wiring defect. Current research instead attributes it to ordinary variation in cross-activation between adjacent brain regions. Grapheme and color areas sit next to each other in the fusiform gyrus, suggesting everyone has some baseline crosstalk, just below the threshold synesthetes cross. The clean separation between your senses that you have never questioned is an architectural choice made by your particular brain, not a law of perception. In 4% of people, that wall is built differently. If the boundary between senses is optional, what other boundaries in your experience were never actually necessary? Every entry on this list found the researchers while they were looking somewhere else. Number 3. Neonatal consciousness. Developmental neurologists mapping fetal EEG in the late 20th century were tracking a clinical target, gestational milestones for brain maturity, used to guide care decisions for premature infants. It was a chart-building project. The working assumption in much of clinical and legal practice, there is, or should be, an identifiable point at which a developing brain crosses into conscious experience, a line regulators and ethicists could draw. Instead, the data produced a smear, not a line. Pain behavior, withdrawal, stress hormone release appears from roughly 24 weeks gestation, a figure cited directly in late-term abortion legislation in multiple jurisdictions. But EEG data tells a murkier story. Activity between 24 and 28 weeks is discontinuous, trace alternans, gradually shifting toward continuous patterns after 30 weeks, patterns associated with the thalamocortical connectivity that global workspace theory identifies as a requirement for conscious broadcasting. Researchers proposed pain behavior itself as sufficient evidence of experience. Blindsight research undercuts this directly. Behavior and conscious experience are demonstrably dissociable in adults with intact, functioning bodies. Others propose the EEG continuity threshold as the marker. But continuous EEG is a correlate observed alongside consciousness in adults, never independently confirmed as its cause or requirement in a fetus who cannot report anything. A third proposal treated the wave transition itself, from discontinuous to continuous EEG, as the decisive marker. But that transition is gradual across roughly 10 weeks, not a switch, and no study has shown it corresponds to anything other than increasing connectivity, which is necessary for consciousness on most theories but has never been confirmed as sufficient for it. No measurement, not behavior, not EEG pattern, not connectivity map, has been validated as proof of subjective experience one way or the other, in fetuses or in infants through their first year of life. One of the most consequential questions in medicine and law. When does someone start being there has no scientific answer, only proxies nobody has confirmed are real. The pattern holds even in the case that should be easiest to solve. Number 2. Echolocation in blind humans. Researchers studying sensory substitution in blind populations were investigating a practical rehabilitation question. Could training improve navigation using non-visual cues? It was applied science, not a search for cortical rewiring. The prediction, the visual cortex, deprived of visual input from birth, should sit largely dormant or get repurposed for entirely unrelated generic processing. Instead, fMRI work by Lore Thaler at Durham University, published in PLOS One in 2011, found that congenitally blind expert echolocators, people trained to navigate using tongue clicks and reflected sound, show strong activation in visual areas V1 and V2 when processing echo information. Sighted control subjects listening to identical recordings showed no such activation. Expert echolocators in the same and subsequent studies identified object size, shape, and surface texture from clicks alone at accuracy levels approaching visual identification in sighted subjects. Some proposed the activation was incidental noise, unrelated to the task. Ruled out activation tracked precisely with the timing and spatial content of the echo, matching task-relevant processing, not background noise. Others proposed the blind brain simply repurposes idle cortex for anything at all, with no deeper meaning. But the specificity, visual cortex for spatial echo information, not auditory cortex handling it alone, suggests the region processes spatial computation itself, regardless of which sense delivers it. The visual cortex was never really about light. It is about space. Denied one channel for that information, it recruits whatever channel is available. If the region you call visual doesn't actually require eyes, how many of the labels you use for your own mind describe the input rather than the underlying machine? And the final entry returns to where every night of your life already takes you. Number 1. Lucid Dreaming. In 1975, Keith Hearn at the University of Hull was studying REM sleep physiology, routine polysomnography, tracking eye movement and brain waves during ordinary sleep cycles. He was not trying to open a channel to a sleeping mind. The standard assumption, consciousness during REM sleep, if present at all, is disconnected, non-volitional, and incapable of directed communication with the outside world. Dreams happen to you. They are not something you direct while reporting out in real time. Hearn arranged a signal in advance with a subject, move the eyes left, right, once you realize you are dreaming. During REM sleep, eye muscles remain active even though the rest of the body is paralyzed. The subject, asleep, sent the signal. Hearn recorded it on the polygraph, live. Stephen LaBerge at Stanford confirmed and extended the result through the late 1970s and 1980s using rigorous polysomnography. Later, Egwerk identified a distinct signature during lucid dreams. The low-frequency theta of ordinary REM combined with high-frequency gamma activity in the prefrontal cortex, a region almost silent during standard dreaming. Skeptics proposed the reports were false memories constructed on waking, not real-time experience. Ruled out by the live, prearranged eye signal confirmation, the communication happened during sleep, not after it. Others proposed lucid dreaming was a light, near-waking state, not true sleep. Ruled out by the paralysis and REM-typical physiology present throughout, confirmed by polysomnography. The prefrontal cortex, normally offline during dreaming, reactivates and enables metacognition and voluntary control while the body remains paralyzed by rematonia, a hybrid state, sleeping and self-aware at once. Consciousness able to communicate with the waking world from inside sleep exists in a condition where, by every standard model, it should not be possible at all. 10 entries. 10 separate research programs, decades apart, studying separate questions, arriving at the same underlying fracture. Not one of these cases sits at some frontier of unexplored physics or biology. Every one of them lives inside the most ordinary, well-mapped territory of neuroscience, a stroke ward, a sleep lab, a routine imaging study. The anomaly was never hiding at the edge of the map. It was sitting in the middle of it the entire time, underneath assumptions nobody thought to test. The rubber hand, the missing half of a room, the hand at its own throat, the eyes signaling from inside a dream. None of these are glitches in the universe. The universe is not confused about what a body is, or where a mind is located, or when awareness begins. We are. The confusion is entirely ours, built into instruments we haven't finished calibrating and theories we haven't finished testing, aimed at the one object we can never step outside of to examine. If you want to see more videos like this, click the video on screen now.